everyone. How are you all? I hope you all are good. You all are doing very well. So, students, do you remember that what we have discussed in the last session? Because we are doing this chapter from the last two sessions, exactly. That is the separation of the substances. So, we are continuing with the same chapter that students that we have left with some of the techniques which we have to discuss. So, we have already discussed about the sedimentation, decantation, filtration, and what else? Do you remember some of the techniques and why we use such techniques? So yeah, we have discussed all of such things that the type of the techniques which we are using and why we use such techniques so that we can separate out the substances. Okay, or we can say that to separate out the impurities or to separate out the unwanted particles or unwanted components from it. Exactly, that's why we are using all such techniques now. So students, the thing is that we are having some more techniques which we are going to discuss in today's session. Fine. So, are you excited? Or if I ask you, have you applied any of the technique at your house so that you can find any result that whether mom is teaching correct or not? That whether we are getting some result from all these techniques or not? Because all these techniques which we have covered up in the last session, so all of the techniques can be used in our houses as well for different purposes. So that's a student, the same techniques we are going to study today, and by using all such techniques you can separate out the components. So it's like first is sublimation, second is magnetic separation, separating funnel, crystallization, and distillation. So all such techniques we are going to study today. Fine. So are you ready, students? Or if I ask you one question that you are having any doubt for the last technique, so you'll say, "Ma'am, we have already posted our question, and our doubts are getting resolved." So that's good, students. If you are following my order, not like order, but my suggestion. Okay. So starting with the other technique. So first is the sublimation. So students, like we have no, like we have already seen what some vaporization is, what is condensation, and we have seen the transferring of the liquid to the vapor state, vapor to the liquid state. Now, student, it's a very interesting thing to see that it is also a kind of process that solid directly convert into the gaseous form, and the gases also directly convert into the solid form, and this process is called as the sublimation process. So now, student, this sublimation process can also be used as a technique to separate out the substance. Now you'll say, ma'am, how? I say, students, sometimes for now, I used to say up, so that's why it happened with me. So just ignore this thing. So now, what's the sublimation is? So as I told you, solid to gases or gases to solid, so we call it as the sublimation process. Fine. Now in the sublimation process, what we have to do is, or what we have to think. See, we have to separate out such substance which is having the property so that it can undergo the sublimation and it will directly convert into the gas. Exactly. If the sublimation property is not there, so how we can use the sublimation process? So what's the sublimation is? Sublimation is the transition of a substance directly from the solid to the gas form without passing through the liquid state. That it will not convert into the liquid state first, it will directly convert into the gas and from the gas to the solid. So that is the sublimation. Now, students, we are having some of the examples that the substances which undergo the sublimation. One is the camphor, and another is the naphthalene ball, students. Fine. But if I tell you that how we can use this technique, that how can we use this process as a separating technique? So now, student, as you can see here, that this is the ammonium chloride salt. Okay, this is the ammonium chloride salt. And if I add something into it, for example, I'm adding salt into it. Okay, now I have to separate out the salt and these ammonium chloride salt. So now we know this thing that the ammonium chloride is having the property that when we heat it, it will directly convert into the gas from its solid form. So that is why, student, here we are using the sublimation process, because what will happen, student, that when it is like when we heat it, so it converts into the vapor form in the gaseous form, and the salt will remain here. So that's how, students, we are separating out the common. You'll see, ma'am, ammonium chloride is also a salt, so I'm talking about the common salt here. So that's how, student, common salt will left behind, and the vapors of the ammonium chlorides are getting formed. So that's how, student, we can separate out such things in which we are having the mixture of one substance which cannot undergo the sublimation, but the another component can undergo the sublimation. So that's how you can use this technique, so that you can separate them out. But for that, student, you know that which type of the substance or what substances are undergoing the sublimation process. As I have told you, camphor, naphthalene ball, now the ammonium chloride salt. So these all are the components which can be directly converted into the gas form from the solid state to the gas form by heating it, so that, student, you can separate them out. So this is a sublimation process, student. And see, if I ask you that will you be able to convert the vapor form of the common salt? Exactly, no. That's why, student, always remember this thing, that this technique can be applied only at that mixture or only on that condition where we are having one component which is having the sublimation property, that it will directly convert from the solid state to the gaseous state. Fine. If it happens like we are having some like mixture and both of them are not having such properties, so how you are going to separate them? Exactly. So that is why one of the component must be having the property of the sublimation, that it will directly convert from the solid to the gaseous form when we heat it. Fine. So this is the first technique which we have covered now, that is the sublimation. Now coming to the another technique. So it's the magnetic separation. Now magnetic separation, student, how? That in the magnetic separation, student, we use the magnet. We use this magnet. Now student, we know this thing, that the iron substances are very attracted towards the magnet, that they feel the magnetic force very easily, and they just attract towards the magnet. Okay, so what happens, student? This magnetic separation we generally use to separate out the magnetic substances and the non-magnetic substances. Fine. As you can see here, that this is the mixture of the iron and sulfur. Iron pieces are there, that is the iron plus sulfur. Now you have to separate them. So now you'll thinking that iron is not dissolving into water, and even though I can't separate out the iron pieces that are very small in nature with my hand. So now what I can do is, so immediately you think, oh yes, iron can be separated by using the magnetic separation, because iron is attracted toward the magnet, but the sulfur is not attracted toward the magnet. That the iron is the magnetic material, but the sulfur is non-magnetic material. So if I use the magnet, so the iron particles getting attracted towards the magnet and the sulfur will left behind, and that's how I can separate it. Exactly. So same thing has been done here, student. We have used the magnet, and the iron particles, as you can observe, they are attracted, or they are, you can see, they are just, you can say that they just paste over the magnet. And that's how we can separate out the iron fillings, and we can separate out the sulfur, because sulfur is not the magnetic material. It is a non-magnetic material. That is why sulfur is not getting attracted towards the magnet. And that's how you can see the separation over here. So student, magnetic separation technique we use in such type of mixture when we have to separate out the component. And what type of components? So it must be like, it should be a mixture of the magnetic one and the non-magnetic one. If both of them are non-magnetic ones, so how you are going to separate them? Like they, by using magnet, you can't. And if both of them are magnetic, so how? So that's a, student, one should be magnetic and another one should be non-magnetic, so that one of the component which is magnetic in nature, it will feel the magnetic force towards the magnet and it will get separate out. Fine. So magnetic separation is the process of separating components of a mixtures by using magnets to attract the magnetic material. The process that is used for the magnetic separation detaches non-magnetic material with those that are magnetic. Obviously, student, that is, there is the separation of the magnetic one from the non-magnetic one. And even though, student, this magnetic separation is also generally used by the doctors. How? Like if a worker is working any of the iron industry or a factory, so what happens, student, that okay, so I can write down here it as the hospitals we use this method. Like if by chance it could possible that the iron, that a very small iron piece can enter their eyes or by mistake. So what to happen that it will start causing problem to their eyes, itchingness will be there, or you can say that it will be a worst condition. So what happens, student? So doctor uses magnetic technique. How? That they use the magnet and they just start moving over the eye of the worker, so that the iron will feel the magnetic force and it will come out from the eye. So that's how, student, this magnetic separation or this technique for the attracting of the magnet from the magnet, like attraction of the magnetic material to the magnet, we use this technique usually in such condition. Like I have told you the example of workers which are who are working in the iron industry. So there are maybe like high possibilities that they can have any iron particle into their eyes or something like that. So people, oh sorry, not people, because all of the people are not doctors. So doctors generally use this technique. Fine. So that's how, student, magnetic separation is used to separate out the components when we're having a mixture of magnetic one and the non-magnetic one. Fine. Good. Now the another type of the technique, that is the separating funnel. Now you will say, ma'am, we are studying some different techniques. Yes, they are very nice. Like when you are going to higher classes, definitely, student, you are doing the experiments related to such techniques. If you are having science stream, not because 11th and 12th you are having science only, but if you are going to for your higher classes in your colleges and as well, so at that point if you are taking chemistry, so obviously you are going to have the experiments of all such techniques. So now what's the separating funnel, student? So separating funnel, we are calling it as the separating funnel because in that funnel we separate the substances. How? As you can see in this picture that it is the funnel. Okay, in this funnel you can see that there is the two layer. One layer is of the oil and another layer is of the water, and there is the knob and you have turn on this knob, so the water is getting flown down. So this is the apparatus of the separating funnel, student. Now, why we use this separating funnel? So as you can see, two immiscible liquids, that are liquids which are not miscible with each other, which are not mixing with each other. For example, oil and water. Oil and water. So students, when we have to separate out such immiscible liquids, example oil and water, we use this technique. Why? Because, student, what happened that when we are using this technique, so we use one funnel and in that we add oil and water, like the mixture of that into it. So what happens, student, when you start shaking it and when you keep it undisturbed for some time, so after some time what you will see that there is the formation of the layer, like it's the layer of the water and it's the layer of the oil, that the denser one will occupying the higher layer. Like the you can see now that the oil is denser than water, so it is occupying the higher layer. So students, when you see such separation, now you can separate them out. How? You can open the knob and the water is getting flow down, and when you see that almost all of the water has flowed on, so you have just turned off the knob, and after that you can take out the oil from it. So at that place, separating funnel method is used up. In what condition? When you have to separate the two immiscible liquid, that means those liquids are not mixing with together properly. Fine. So two immiscible liquids such as oil and water can be separated by using a separating funnel. Later, the mixture is placed in a separating funnel or colloquially sep funnel and allowed to stand. That the name of the separating funnel is the colloquially sep funnel, so don't get confused about it. And when you keep it undisturbed for some time, so there will be the formation of the layer, and what will happen, student, that the denser one will occupy the high layer, or we can say that the above layer, and the lighter one will occupy the lower layer. Okay, so if we talk about the oil and water, so in that condition, which one is more denser? So obviously, oil is more denser than water. So oil will occupy the above layer and water will occupy the lower layer. So that, student, what you can do, you can turn on the knob, and the water is getting flow down, and the oil will remain there. And after that, you can separate out the oil from the funnel also. So that's how, student, this separating funnel is used for the immiscible liquids. That when we have to separate out the immiscible liquids, we use this method. Fine. So we have talked about sublimation, magnetic separation, and the separating funnel. So student, you can observing one thing that for each and every type of technique, we are having different type of components. Like for the sublimation, we require the component which can undergo sublimation. For magnetic separation, we require such type of mixture in which there is some magnetic material. Then only we can use the magnetic separation. Now when we talk about separating funnel, so for that we require the mixture of immiscible liquid. That means student, for each and every type of mixture we are having techniques, different techniques, so that you can apply it and you can separate out the mixture. Okay. Now the another technique. Okay, so it's the crystallization, students. So in the crystallization, students, what happened that the crystallization from solution is the separation technique where a solid phase is separated from a mother liquor. Now you say, ma'am, what is the mother liquor here? So don't worry, I'll tell you. See, as you can see in this picture, this is the solution of one solid and insoluble impurities. Okay, let's say it is a mixture of copper sulfate. Fine. When you filter it out, so what will happen? Well, now you know what's the filtration it. So the impurities will left behind and you are having the copper sulfate solution only. This is the copper sulfate solution. And when we are having when there is no impurities are there and we are separating the impurities and the pure one, so what happens, student, in that condition, you are having this solution and this solution is called as the mother liquor. Okay. And now when you heat this mother liquor, so there will be the formation of the crystals from the solution, and this process, that the formation of the crystals from the mother liquor, and these crystals are present in the solid form, so we call it as the crystallization process. And see, student, crystallization process generally we do in what condition? When we have to obtain the pure compound, pure crystals from the impure one, or from the, you can say, from the impure one or the mother liquor, as we have seen already. Fine. So you can see, student, here that when you heat it, so you will observe that there are forming of the crystal, and after some time when all of the water, that the extra amount of water which has been evaporated into the atmosphere, you will find out that there is some moisture, and when you keep that for cooling, so after some time you will observe that there is the formation of the crystal of copper sulfate. So that's how, student, you can do this crystallization process. And you will get the crystals, and these crystals like look very beautiful as well, because they are shiny in nature and they are forming small crystals. So crystallization technique is generally used when we have to separate out some pure crystals from the impure one, even though we have separated out the impurities, but when we are having the extra amount of water into the mother liquor, so we have to evaporate it so that we can get the crystals. So this is the crystallization process. Then when we are getting the crystals after the evaporation of water, so that's how, student, we call it as the crystallization process. Fine. Now it's the last technique which you have to learn, that is the distillation process. So if you remember one thing, student, that the separating the funnel, as I've talked about the separating funnel just now only, that we use that technique for the separation of the immiscible liquid. Okay, that the liquids which are not miscible with each other. So student, this distillation is used for the miscible one, that the liquids which are miscible in nature, miscible liquid, we use this technique to separate out such liquid. That means when two liquids are there and and both of them are miscible with each other, both are mixing with each other, then we use this distillation method to separate them out. Okay. So distillation is the process of separating the components or the substances from a liquid mixture by using the selective boiling and condensation. How? I'll tell you now. For example, okay, I'm just taking one example. I'm having a mixture of acetone and water. Okay. But student, remember one thing, for the distillation, when we are having, like when we are separating the two liquids, so they must have some difference in their boiling point. Why? Because acetone is 78 degrees Celsius, and water, we know it is the 100 degrees Celsius. Okay, and we are mixing it. Fine. So now when you're having the mixture of the acetone and water, A for acetone, W for water. Okay, when you're having the mixture of it and when you are heating it, student. So what happened, that first of all the temperature would be 78 and after that it would be 100 degrees Celsius. So when the temperature is reaching to 78 degrees Celsius, so what will happen? There is the formation of the vapors of acetones, because acetone is the liquid, it is a liquid, and on heating, students, we know this thing, then when we heat this acetone, so we are getting the vapors of it. Exactly. So we are getting the vapors from here. That means we are doing the boiling process. So when we are getting the vapors of acetone, so that vapors are going to transfer this in this part, and this part is called as the condenser part. That means in the condenser, condensation process take place. And if you remember what is the condensation, that the vapors get cooled down and they again convert into the liquid form. So when the vapors of the acetones are transferring to the condenser, and in the condenser condensation is going on, so what will happen, that the vapors of the acetone again convert into the liquid, and you can see here that in this flask you can collect the acetone. Fine, students. But now in this technique, student, what you have to you have to remember, or you have to see it very carefully, that when the temperature is 78, and when all of the vapors are convert of the acetone into the when all of the liquid of the acetone converts into the vapor, you have to stop heating, because if the temperature is going to be rise up, so it will come to the point when it is reaching to 100 degrees Celsius, and at that point, student, definitely you are having what, water. So that's how, student, water is also getting evaporate. So that is why, student, we have to use this technique very carefully, so that we can separate out the two mixing liquid or the two miscible liquids properly. So that's how, student, we use this distillation process, and this is also called as the simple distillation. But in the simple distillation, student, what you have to remember is that the liquid which are mixing together, or the mixture is there, so they must have some difference in their boiling point, so that it will take some time for rising in temperature. That means, student, when the temperature is 78, so now it will take some time to reach to 100 na, and in that time you can separate out the acetone vapors from there, and you can condense them and the liquid get formed. So that's how there should be difference. But, student, if I say there is A and B, A is having 50 and the another one is having 52 degrees Celsius, so how it is possible to separate them out by using this simple distillation? Because 50 is there, and within a minute it is going to like 52. So that's a, student, we can use this distillation process for separating those components of the mixture or the liquid mixture, because we are using two liquids in this. There is no solid present here. So when we are having the two liquid mixture which are miscible in each other, so we have to use the boiling process first, so that the component which is having the low boiling point, first it will get evaporate, and then after that the substance which is having the high boiling point, it will left behind. Exactly. Because the temperature is first of all going to reach the 78, then it is going to reach the 100 na. So when it is 78, acetone will get evaporate, and the vapors will transfer to the condenser, and the condensation take place, and that's how we are separating it. So important thing is what, miscible liquids are there, boiling is done, condensation is done, and very important, there must be the difference in their boiling point. Okay, so that you can separate them out easily. So this is the simple distillation, students. So I think so with that we have completed all of the techniques, and all of the techniques are very interesting, I thought. So now here are some questions. How will you separate sand and water from their mixture? Oh my god, we have discussed already this thing. So sand and water mixture can be separated out by using the sedimentation and decantation method. Exactly. The mixture is allowed to stand without any disturbance. Like first of all, we don't have to disturb it. Now sand settles down, so now what's done, we have done the sedimentation. Exactly. Now slowly pour the water into another container to obtain sand in the bottom. So now what we are doing, decantation. So by using sedimentation and decantation, we can separate out the sand from the water, because sand is insoluble solid. So that's how we can separate it out by using sedimentation and decantation. Okay. How would you obtain clear water from a sample of muddy water? Now we are having muddy water and you have to obtain a clear water from it. So now what you can use is, obviously, student, we can use the sedimentation again, that the process should be carried out to obtain clean water from muddy water. Allow muddy water to stand. So like it is a beaker, and at the bottom there is the sand, and over that there is the clean water. So it is settling down at the bottom. Muds get settled down in the water. This is the mud, and this is the water. This is the what type of water, clean water. Now you can slowly pour this clean water into another beaker, and this is the decantation, and this is the sedimentation. Now if you want to filter it more, like if you want to make it more pure, so you can do the filtration process for that. Like you have to use the filter paper so that the small impurities will also getting separated out from it. So that's how, student, you can follow all these steps and you can separate out the clean water from the muddy one. Okay. Okay, that means, student, we have done all of the question. We have discussed all of the techniques. Now what you have to do is you have to watch these sessions very carefully, and because we have completed this chapter as well, and all of these techniques are very interesting. You can learn these techniques here, and definitely you are going to see all such techniques in your high classes. And student, now what you have to do, that if you are having any question, any doubt, you can post your question on the public or private forum of Ask IITians, and you will get the answer from the expert side. And definitely, student, all such techniques are interesting and you will be enjoying it. Okay, so just keep studying, and what else, keep learning from Ask IITians. Thank you for attending this session.